class, we discussed regarding the data types, arrays, as well as time. So whenever we are going to consider the data type time, in that case, we will be able to get the current simulation time. So when we want to get current simulation time of the software, then we can use the task $time. So it is a system task. It will going to give the current simulation time, and it can be saved in the variable of type data type time. Okay. So here whenever we are going to declare any particular variable of type time, it has to remember the time what we have considered, isn't it? For example, if you want to see how long a particular code will going to run. So for that, what we are going to do at the beginning, before starting the execution of the code, the first line to be executed is it has to collect the system time, and it has to store that as the starting time. And then after complete execution of the code, once again it has to read the system time. That will become the ending time. The difference of these two will give the time duration taken by the code to run, isn't it? So this is how to get the value. We are going to use $time to get the simulation time, and to save the time we are going to use the data type time. Okay, and the keyword what we are considering is time, and it belongs to a register data type, not a wire, because it has the value has to be remembered. So it will belong to a register data type. And next what we discussed is arrays. So whenever we are going to consider arrays, in that case, here if n number of objects or variables has to be declared, and all of them belong to a same type of data, means it can be integer, or it can be a register, or it can be wire and all. So in such case, we are going to consider arrays. So array declaration is specified in this example, that is count, integer, count, and then we are mentioning dimension of the array. So when we consider array, it is different from a vector. Vector means it will be representing only individual variable. Okay, individual variable and its corresponding size. How much data it can hold, that represents the vector dimension. But here, this represents the array dimension. So for the vector declaration, we can see in this example, which I have typed in the above. So here I can have mentioned integer 0 to 7 count. So it indicates that count is only one variable and it can hold 8-bit data. But in this example, in this block, what I have mentioned, integer count 0 to 7. So here it indicates that there are 8 different count variables, and each variable is of type integer. So like this, we are going to consider the array declaration. So if we mention the dimension after the keyword integer, it indicates size of each variable. And if you mention the dimension after the variable name, it indicates we are declaring an array. Okay, and the dimension indicates how many elements are there in array. And similarly here, if you want to consider array of time variables, so in that case, I can consider the data type time and the corresponding variable name and the corresponding size. So in that case, in this example, we can see that there will be around 100 different checkpoints where we want to save the corresponding time. Means when we are considering a long code or a lengthy circuit, in that case, its functional description will be very large. So we want to check how much it will going to take for each type of function. So in such case, we need many number of checkpoints. So there we can use this particular declaration, that is time and the corresponding checkpoints. So here there will be 100 checkpoints, and each checkpoint is belongs to a data type time. And similarly, in this fifth example, we can see that register 4 down to 0, port ID 0 to 7. So this indicates there are 8 different port IDs and each port ID is of size 5 bit. So like this we can able to mention the dimension. See, in case of integer, it's by default 32 bit. But when I consider register, if I do not mention the size, in that case it indicates only 1 bit. So if I mention 4 down to 0, it indicates every variable is of 5 bit. So like this we are going to consider the difference between vector and array. And also one more thing what we have to consider is, when we are using array, it can be a unidimension or multi-dimension. But when we consider a vector, it is only one dimensional. Okay. So here, let us consider one more example. So in this, we can see that integer matrix 4 down to 0 and again 0 to 255. So here, it indicates we are considering a matrix of 5 different rows and 256 different columns. So in each row there will be 256 elements. So like this we are going to get my 2-dimensional array, and each element in the array is of type integer. So if I want to access the first element, I can mention it as matrix 1. Matrix within the first bracket indicates the corresponding row number and the second bracket indicates the corresponding column number. So in that I am trying to set the value, integer value for that particular position. Similarly, since this is a 2-dimensional array, if I mention this as matrix only 1 dimension, so in that case it is an illegal, because in one row there are 256 different elements. So we cannot set all the elements at a time by declaring using only one row. So that is why this type of writing code is illegal. Like how we declare 2 dimension, similarly we can consider 4 dimension, 5 dimension. According to the requirement we can going to consider. And here one thing what we have to observe is, this is a 4-dimensional array. So how the concept of 4-dimensional array can be considered here? So whenever we are considering a 4-dimensional array, means it will be a larger matrix, and in this matrix every element itself is a matrix. Okay. So if every element itself is a matrix and the outer matrix consists of only one particular row, means it will become 3-dimension. If it is having more than one row, then it will become 4-dimension. So like this we can able to consider multi-dimensional array. So in this I want to access only one particular variable. So there I can mention it as array, and here the first one indicates the corresponding row number of the outer matrix, and the second index indicates the corresponding column of the outer matrix, and the third index indicates the corresponding row of the matrix element, that is inner matrix, and the fourth column indicates the corresponding column in the inner matrix. And in that I am mentioning 15 down to 0. See, here every element in this 4-dimensional matrix is of 64 bit. I want only 16-bit data to be set at 0. So what I am going to do, first I will mention the dimension, and then I will mention the corresponding size of which I want to reset as 0. So this indicates that the first 4 will indicate the dimension and the 5th one will indicate size, because in this matrix we can see only 4 dimensions are used, and this each value is of 64 bit. So to represent that I am using this 15 down to 0. If I do not mention 15 down to 0, what happens? It will allot 0 for complete 64 bit. I want to reset only 16 bits, not the other bits. So in that case I can mention the dimension. So like this we can able to consider not only register data type, even for wire also we can consider arrays. This is regarding the data type array. Next, what we are having is memory. Memory is also similar to a register, but it is of one dimensional. Because whenever we are going to discuss about memory, we are going to tell that is 1 kilobytes of memory or 1 gigabytes of memory. Like this we are going to consider, isn't it? So as a result, we are going to consider only a data type register, and it will be of only one dimension. And the size of each memory is represented before the corresponding variable. So here between the keyword reg and the variable mem byte, we are mentioning the size. So size of each memory byte should be equal to 8 bit. So here we are declaring 7 down to 0. If we do not mention this, what happens? It will going to allot only one bit for every memory element. So in that case, if I mention as register mem 1 bit of 0 to 1023 means it will be having 1024 locations, and in each location I can save only 1 bit data. But here in the second example, what I can do, if I consider register 7 down to 0, mem byte 0 to 1023, in that case it indicates there are 1024 memory locations, and each location can have 1 byte of data. So like this we are going to consider. And similarly, we are having, if you want to access any particular memory byte. So in that case, I'll just mention the variable name and the corresponding element. Means I want to access only 511th element. So if I mention mem byte 511 means whatever 8-bit data present in that particular memory location will be considered. So like this we can able to access the memory. So memory and array declaration are same. The only difference is if I consider it as array, it can be one dimension or multi-dimension. But if I consider it as memory, it can be only one-dimensional array. Okay. Again, one-dimensional array and one-dimensional vectors are different. Even though vector is a one-dimensional, here it represents only one variable. But when I consider a memory as a one-dimensional array, it represents many variables. Okay. So that is the difference between the memory as well as vector. And next, what we are having is parameter. So parameter is similar to a constant keyword. If you want to pass any data, for example, if I take variable, so the name itself indicates the data can vary. But if I want any particular constant, see, whenever we want to access 8-bit data at a time, so in that case, what I am going to do, I will mention the width as 8. And whenever I am going to mention array of width or a particular variable of width, then it will going to take only 8 bits of data. So like this, when the number of bits are specific, or if I want to multiply with a particular constant in any arithmetic operation or multiplication like division operation and all. So in that case, every time remembering a particular value will be difficult. But if I declare it as a constant, whenever I want, I can easily remember the name and I can use that name in the program. So that is why we are going to consider constants. So here in Verilog, we do not have a keyword constant. Instead of that, we are having the keyword parameter. Okay. So in this example, we can see that parameter cache line width is equal to 256. So this defines that the width of the cache line, that is nothing but when we are going to consider cache memory and all. So in that case, here the cache line width means it indicates the cache memory width is of 256. So whenever I use the variable name as cache line width, it will represent the value 256. Okay. And similarly, we are having parameter signed 15 down to 0 width. So here, what it indicates is we are considering signed data, and each data is of 16 bit. Okay. And name of the corresponding data, what I am signed 15 bit, I am representing it as width. Wherever I am going to mention width, it will going to represent the corresponding 16-bit signed value. So if I declare any particular variable of type width, or if I mention width anywhere in our program, it will always consider it is a 16-bit signed data. Okay, so like this we are going to consider parameter. And also, for example, when we are going to use some expressions like sin 2 pi or sin 3 pi and all. So most of the time we will be using the value pi. So but in Verilog directly I cannot mention pi. So I can define it as a parameter. So here I can mention it as parameter pi is equal to 3.77. So if I mention like this, wherever I am going to use the variable pi, it will be considered as 3.77. So whatever the value, if I define it as 5, so whenever I am going to use the variable pi, it will replace that variable by the value 5. So like this, we can declare the parameter. Okay, and while executing, we cannot change the value of parameter because it is a constant, isn't it? So it remains constant throughout the program. But whenever we want to change the value of a constant, before execution only we can change. Okay. And when suppose, see, previously I took the value of pi as 3.77. So while executing, wherever pi is there, it will take 3.77. Now I want to change that value to 5. So in that case, I can change before execution and run once again. So in that case, what happens? Wherever this variable is there, it will replace, instead of 3.77, it will take it as 5. Okay, so like this, we can consider the parameters. And there are many advantages while considering the parameter. And whenever we are considering Verilog module, so this we know that one module can call another module as an object, isn't it? So when we are calling one module inside another module, that is nothing but module instantiation. In that case, for one instantiation, we want to use some different parameters, and for another instantiation, I want to use another parameter. So in such case, what we can do is, if I want to change the value of parameter, then I can use def parameter. So def parameter is nothing but define parameter. It will going to change the value for every instance according to the value what I have mentioned. So here in this example, we can see that module hello world and the parameter id num is equal to 0. So we have taken the id number as 0, and then it will going to display. So that in this particular code, initial $display will display a particular string. So in this, it will displaying the hello world id number as %d, and wherever this id number is there, it will replace by 0. In this example, continuation of that example, if I consider here, first I have defined a module hello world, and next I am using that module and I want to change id number present in hello world. So for that, what I am using? I am using def parameter. So here in the module top, I am considering def parameter w1.idnum. So w1 indicates instance name, because whenever we are calling a parameter, we are going to mention instance name, isn't it? So whenever we instantiate, so that is why for this particular instance, ID number should be equal to 1. And for instance W2 dot ID num, it should be equal to 2. So in the first module, what we have defined, in the hello world module, we have defined ID num is equal to 0. Okay. And observe here, there are no IO ports for this module. Okay. Module, hello world, and then the parameters, and then I am displaying. So it will just only display the parameter value. Okay. And in this top module, what I am doing, I am calling the module hello world. With the, since twice I am calling, I am mentioning the instance name as W1 and W2. And now I want to change the ID number from 0 to different value for every instance. So using this def parameter, I am mentioning instance dot the corresponding parameter and its value. So when we execute this top module, we will be getting output like this. Displaying hello world ID number. Here for the first instance, I have changed the parameter from 0 to 1, so it will display as 1. And for the second instance, I am changing the value from 0 to 2. So it will going to display it as 2. So like this, we can change the value of parameter using def parameter. Otherwise, the value will remain constant. Okay. Next, one more place where we are going to use the parameters. That is nothing but whenever we are going to consider a constant value, or you might have heard about state machine diagram in case of digital electronics. So there we are going to use state machines. There the state number will be constant. State output, it can vary depending on the input. So if there are 5 different states, means the state number will remain constant. So in order to indicate such type of parameter, we are going to use local parameter. Previously, if I use parameter, it is a global parameter and this is a local parameter. So where we can use such parameters means, see, Verilog HDL local parameters are identical to parameters except that they cannot be directly modified with the def parameter statement or by the order or any named parameter value assignment. See, in the previous example, we have observed the value of parameter we can change using def parameter, but for the local parameter we cannot change. Okay, they are local to that particular module, so that cannot be changed in some other module. In the previous example, what we did is we changed the parameter value in the top module. Parameter was defined in module hello world, but we changed its value in another module by using def parameter. Okay, but we cannot access local parameter like that. Okay, and it is defined by the keyword local parameter and we cannot change those values using def parameter. And this is one of the example of state machine. So when we want to represent 4 different states, I can consider 2 bits. So I can represent state 1 as 0, 0, state 2 as 1, 0, state 3 as 0, 1 and state 4 as 1, 1. Either I can consider that type of notation or else for every bit I can assign the corresponding, which particular state is active, can be indicated by individual bit. So in this example we can see local PAREM, then the variable state 1 is equal to 4 tick B 0001. It indicates that state 1 is active and other states are not active. And similarly for state 2, state 3 and state 4. So like this we can able to define local parameters which cannot be accessed by any other module. Okay. Because these local parameters should not be changed according to the change in external environmental input. It has to work it has to consider the constraints defined only in that particular module. So that is why. Okay, this is one example of parameters. And the next, what we are having is strings. So when we are going to consider strings, as I told, we can string represents a set of characters, and always the string should be represented within double quotes. And also, I have already told that each character in the string represents a ASCII value, and each ASCII value is of bit 8-bit. Okay, so that is why strings are also considered of type registers, because it has to be stored, and width of the register depends upon length of the string. Okay, if the string is large, the width of the register considered to store the string is also large, otherwise less. And each character, since it is ASCII value, it will be of only 1 byte width. Okay. And here, if the width of the register is greater than the size of the string, see, while declaring, if I just mention reg 16:1, and then if I mention the corresponding variable, let us consider char. So char represents a 16-bit variable. Okay, sorry. Yeah, 16-bit variable. So now what I am going to do is, I'll just assign char is equal to some value, SOME. Okay, let us consider this string. So here, what happens? How many characters are there? There are 4 characters, and each character is of 8-bit. The variable char is only of 16-bit, not of 8-bit. So what it will do? It will going to take the lower to 16-bit and upper 16 bits are discarded. Okay, so that is why if the width of the register is greater, then it will fill. What is the leftmost is there, that will be filled. Otherwise, it will truncate the leftmost bits of the string. So like this, if the width mismatches, then it will, according to that, either it will truncate or it will going to fill the corresponding character. Okay, so the upper bits in this, if the instead of giving 4 characters, if I mention char is equal to the string L. Okay, so in that case, this is only 1 bit and 8 bit, and this is of 16 bit. So what it will do for the upper bits, it will going to fill the string with 0. So like this, we are going to consider the string. And next, to display these strings, we are having the special characters. Okay, to display these things, we are having the system task. And here, when we see the keyboard, we can able to observe the alphabets, numbers. Also, we can able to observe special characters, isn't it? So whenever we want to display the special character, then we should know what special characters are considered in this code. So here, the special characters which are having special purpose in the string are new line characters, tab, and if I want to display the percentage, in that case, I can use this percentage, and double percentage if I use, it will be treated as a escaped character. So it will display only the character percentage. And if I mention /t, it will leave a space of 1 tab. And if I mention /n, it indicates it is a new line. Okay. So like this, if I want to display double quotes, I can consider it as /double quote. And if I want, because see, instead of considering slash, if I simply mention double quotes like this, so what it will do? It indicates that we are considering string. It will not display double quotes. So in the previous example also, we might have seen while displaying here. While in this particular example, what we have defined, $display within double quotes I have mentioned displaying hello world ID number equals %D, isn't it? So, but in the output what we can see only these characters, not the double quotes, isn't it? But if I want to display the double quote, then I have to consider this escape character, that is slash, and then I have to mention double quotes. Then we can able to display the double quotes. Okay. So like this we are going to consider, and similarly when we are going to consider the characters in case of octal numbers, so we are going to represent it as /O. Okay. So these are the special types which are present in the string. So if I simply mention any particular values, alphabets, it will directly display. But if I mention /n, it will not going to display that. It will treat it as a new line. Okay. So like this, we are going to consider the special characters which can be used for display. And each character which we are going to display is considered as a string. Okay. And next, what we are having is system, task, and compiler directives. So when we are going to use the system task, okay, so when we are going to use the system task means if we want to perform any special operation, means we want the system to do a particular task whenever it is called. So in that case, we are going to use this system task, and here each system task is invoked using the $symbol and the corresponding keyword. So here some special system tasks are defined. So those system tasks we are going to consider next. But here one of the things why we are considering this system task means, for example, when we are running a particular code, or if you want to display anything, or if you want to read system time and all. See, just for example, on I told reading system time. In order to read system time, I need to write the corresponding code, how to read the system time. Instead of that, if I use $time, I can directly get the system time. Means whenever it identifies $time, it indeed tells for the software or the system what it has to do. So it will do according to the keyword that is mentioned in after the $symbol. Okay. So that is why we are going to use the system task, which will be easy for the designer to write the program. And the corresponding system tasks we are going to discuss are $display to display a one-line string. Okay. And here we can see this example. So mainly this is used to display a variable, string, or expression, but it has to be placed within the parenthesis, and it will display only once. Okay. So whenever we want to display n number of times, we have to use this statement n number of times. So in such case, it will going to display that many number of times. So if I want to display any message only once, for example, if there is any error occurs, so in that case, I need to notify where the error is, or while writing a lengthy program, if some particular type of error occurs, or if some value which you are expected is not happening, in that case, you will be indicating by displaying the message. So this particular alert message we can consider. So this particular value has been occurred, or this type of error has been occurred. All these things we can consider. And one more example what I can give is, if you are comparing two strings, in that case you want to display the message whether both the strings are same or not. So in such case, you can able to display the strings are same or the strings are different. Or if you want to search an element, whether it is there in the array or not. So in such case, you can display the message. If it identifies, you can mention, you can display the variable has been identified and it is at this particular position. Otherwise, you can display the message, it is not present in the array. So like this, it can be used according to the requirement. But whenever we want to display, we are going to use $display. Okay, and the corresponding variables. See, in the previous example, I was displaying the ID number, isn't it? So if I am accessing any particular integer means I have to use that using %d so that it will going to display the decimal value. Similarly, if I use %s, it will %h, it will consider hexadecimal. Like this, we will be having different notations, different in the formats. In this table, you can observe that is %d will display a decimal value, %b a binary value, and %s string. So like this, we can able to display in different format. Okay, and here, whenever we consider $display, after displaying, by the end, it will insert a new line character by default. So if I am executing two display messages, one after the another, it will not be displayed in the same line. Always it will be displayed in the new line. Okay, so that is why by default it will end with the character new line. We need not necessary to pass the new line character. In the previous example, you have observed that here we are displaying display hello world ID number 1. And in the second instance also, we are displaying with different ID number. But both are not displayed in the same line. Even though in our program, we have not mentioned any new line character. After %d, I have not mentioned new line character. But still, it will going to display in the next line. Means by default, it will going to consider the new line character. Okay, like this we are going to consider. And next, these are the different formats what we are going to consider. And this is one of the example. If I want to display a one-line string, here I can consider $display and the corresponding string within double quotes. And whichever you want to display, it should be within double quotes only. Only because it will display only strings. So that is why it should be within double quotes. If I want to display a number or any string or any character or any hexadecimal value, in such case, I need to call by using the format that I have mentioned in this particular table. Otherwise, we can mention any character within this particular double quotes. And similarly, if I want to display the time, I can consider $display, $time. So $display means it will indicate system to display the content present within the double quotes. But within this parenthesis, what I am having? $time. So what $time will do? It will access the current simulation time and that value will be displayed. Similarly, in this, I am mentioning at what particular time the virtual address we are accessing. So it will indicate that at this particular time the virtual address is this one. Because virtual address it can change at any time. So as a result we can do like this.